Okay, we're on 4.5 exponential applications. This is day one, and this is where, like, one of my favorite things, because it talks about money and how we can use math to make money. So that's pretty awesome. There's a couple of different formulas you need to know. The first is compound interest. Okay, compound interest is when every period the interest gets added to the principal, and so it keeps growing. It's a magical thing. You have to know this formula and what all the parts are. Remember though that the interest rate, you change the percent to a decimal. N is the number of times it compounds by year. So is it compounding yearly? That means we only figure the interest every year, that N is 1. If it's monthly, so every month we start over and we add it in and recalculate based on adding it in, so that's 12. If it's quarterly, because there's 12 per year, quarterly means it happens 4 times per year, so that would be N equals 4. And daily we use N equals 365. And I know there's a couple of times every 4 years, or just once every 4 years, that we have 366, but we just use 365 as the norm. And then T is your time in years. So if it gives it to you in months, like let's say they say it's 18 months, that you have to translate that into years, so that would be 1.5 years. So T is your time in years. Continuous compounding means that it's always compounding. You don't just refigure it on a monthly, yearly, or quarterly basis. It's continually compounding. And that's the formula you need to know for that. So those are 2 formulas that you need to have either know, depending on your teacher, you need to either know it or have it on your note card or in your notes, and easily accessible. You'll know which one to use because the problem will tell you it's compounded or it's continuous. So let's apply these. So number 1, you invest $3,500 into a savings account that pays interest compounded. Okay, so we know we're using the compound formula quarterly, which means my N is 4 because it's 4 times a year. So the first thing we're going to start with is a general formula of A equals the principal times 1 plus R over N to the NT. So let's take the information we have and put it in this formula. P is my principal, so that's the 3,500. And then in parentheses, I have 1 plus my rate. If I change 1.2% to a decimal, that's 0.012. Be really careful that you get that right. Over N, I already said my N was 4, to the N times T, so 4 times 5. So you're going to take, and when you calculate this, do this from the inside out. You'll do 0.012 divided by 4, add it to 1, take that to the 20th, because 4 times 5 is 20, and then take that times 3,500. And I want you to actually put that in your calculator and test it. Make sure that you are calculating and putting the numbers in correctly according to order of operations. That's what you should get. Now, the next question is, how long? Okay, so that means we're looking for T. We're trying to get to T. Will it take to have 4,500 in your account? That's the amount we want at the end. So what we're going to do is we're going to take 4,500, that's what we want at the end, equals 3,500 times 1 plus 0.012. We're still working with the same interest rate, over 4 to the 4, because it's quarterly, T. Holy cow, we've got to get to T. All right, so the first thing I'm going to do is take 0.012 over 4 and multiply that times, well, actually, no, that's not the first thing. The first thing we're going to do is try to get this by itself. So I'm going to divide by 3,500. And that will give me 4,500 divided by 3,500 is 1.29. And that's going to be, and then if I take 1 plus 0.012 over 4, that's 1.003 to the 4t. Okay, if I'm trying to get to the t, what I'm going to do is I'm going to take that, I'm going to take the log base 1.29, or actually, to get to the t, I'm taking the log base 1.003 to get rid of that. So 1.000329 to the 4t. Remember that to do a change of base, to fix this, I'm going to have the log of 1.29 over the log of 1.0003 equals 4t. You'll find that and divide by 4, and when you do that, you should get a t of 21.25 years. Okay, let's try another one. You invest $2,000 in a CD that pays 2.7% interest compounded monthly. So I know that my N is 12 and my P is 2,000 and my rate is 0.027. Okay, so if we plug that in, we've got the amount that's going to be there is 2,000 times 1 plus 0.027, that's my rate, over my N, which is 12, to the N times T. My N is 12, my T is 18 months, which is 1.5 years, so that's 1.5. And when you calculate that, you get an A of 208,257. Okay. Now, what interest rate? This time what we're looking for is the rate. So that's the part we don't know. So if I plug that into my, this is what I want at the end. So if I plug that into my formula, the amount at the end is 2,200 equals the 2,000 that I started with times 1 plus my rate, which I don't know, divided by my N, which is 12, and then it's 2 years, so it's my N, which is 12, times my T, which is 2, which means I have, first thing I'm gonna do is divide by 2,000, because I'm trying to get this thing to itself. And I have 1.1 equals 1 plus R12 to the 24. What I'm going to do there is to undo the 24th exponent, I'm going to multiply that times 1 over 24. That's like taking the 24th root. So I'm going to take this to the 1 over 24. And I get 1.004 equals, this will cancel each other out, so then I'm left with 1 plus R over 12. Okay, I'm trying to get to R. So I'm going to subtract 1 from both sides. When I do that, I have 0.004 equals R over 12. I'm going to multiply both sides by 12. And I get that R equals 0.0477. And when I make that a percent, that'll be 4.8% is the rate that I would need to have. Okay, next one. I love this one. Your grandparents put $50,000 for you in a trust fund. Wouldn't we all love to have that trust fund? And it compounds continuously, which means that I'm going to have my continuous formula, A equals P e to the RT, at 3.8%, which as a rate we change it to a decimal, is 0.038 when you were 2 years old. Okay. What will be the value on the 21st birthday? Well, if they did it when you were 2, that means that my T is 19, right? It was 19 years from the time they invested it to the time I turned 21. So if I plug all of this in, I have that my amount is going to be my principal, the $50,000. And then that's going to be times E, and then raised to a power to the 0.038 to the 19 times 19. So you'll take E to that power and then take that times 50,000. And on your 21st birthday, you would have 102,927.31. How cool is that? We all need to have those grandparents. Okay, the next question is, how long? So I want to know what the T is. That's what I'm going to solve for. To triple the investment. Well, if my investment was 50,000, to triple it means I'm looking at how long it's going to take to get it to 150,000. And that's going to be 150,000 equals my 50,000 E to the 0.038 T. I want to know how long it's going to take. So first thing I do is try to get the E by itself. I divide both sides by 50,000. So I have 3 equals E. Let me open this up a little bit. E to the 0.038 T. To get to that 0.038 T, I'm going to take the natural log of E, and I'm going to do that on both sides. This will cancel, so I have 0.038 T. The natural log of 3 equals that. I'm going to divide by 0.038. When I take the natural log of 3 divided by that, I get T equals 28.91 years. So not very much longer, and it'll triple. Whoops, sorry about that. Okay, and that's the end of this session.